Welcome to my channel. Here we are discussing questions from the topic Force and Motion for Edexcel IGCSE Physics examination. That too from the past 4 to 5 years of Edexcel board exam question paper. Before we start, please like and share my videos and also subscribe to my channel so that you can get notification about my new videos. In fact, these videos are good for other exam boards also, since all exam boards include questions from the topic Force and Motion. The link to the part 2 of this series will be given in the description box. I shall show you how to answer these questions. So let's start with question number 1. The diagram shows a man pulling a child on a sledge. The mass of the child is given and the unbalanced force acting on the sledge is given. This is the mass and also the unbalanced force acting is given. State the equation linking unbalanced force, mass and acceleration. In fact, you get these type of equations, some set of equations, you will get it in the data sheet. So here, the relation between unbalanced force, so let us write down the answer, unbalanced force. This is what Newton's second law says. Force is the product of mass and acceleration. Unbalanced force is the product of mass and acceleration. Let us move on to the next part of the question. Calculate the acceleration of the child and the sledge. So we can make use of the same equation what we have written here. Actually, force, it is Newton's second law. Force is the product of mass and acceleration. The force is already given. Mass is given. We have to calculate the acceleration. So for that, let us take acceleration as the subject. So acceleration is force over mass, which is 49 over 45. Please make use of your calculator, and on calculation you will get an answer of 1.1 unities meter per second square. So let us put the answer here, 1.1 meter per second square. Now let's move on to the next part of the question. Suggest a reason why the man must pull the sledge with a force that is greater than 49. So here we have seen that the force applied is unbalanced force acting on the sledge is 49. But he has to apply a force greater than 49 because there may be friction between the snow and the sledge. So this is, there may be friction between, so friction between snow, or I can even say that the ground and sledge. Let us move on to the next part of the question. The sledge is then placed at the top of the hill. When it slides down the hill, it accelerates at 1.3 meter per second square. The sledge accelerates from rest. So let us use the corresponding symbols. It acceleration. Then it is starting from rest. Starting from rest means the speed, initial speed is 0, and the time taken is 2.4 seconds. State the equation linking acceleration, velocity, and time. Acceleration, velocity, and time. So we know that acceleration it is the change in velocity delta v, change in velocity over time. This is the relation. So delta v is change in velocity. Delta represents the change. Then show that the sledge reaches a speed of approximately 3 meters per second after it has accelerated for 2.4 seconds. show that. Show that means you have to get the answer. It reaches at a speed of 3 meter per second means the final speed v. So we have to calculate the final speed v and you have to get it as 3 meter per second. Please remember, in this type of show that questions, the given data is not to be used in your calculation. That is the answer you have to get. So for that, let us make use of the equation what we have written in part 1, acceleration. Acceleration is the change, delta v, change in velocity over time, and the change is the final velocity minus the initial velocity over time. And here, let us substitute the values. Acceleration is already given. So now the change in velocity, we don't know what is the value of v. This is what we have to calculate. So we have a equals v minus u over t. Now while calculating, I can give you another way of calculating this using Stewart equations. The first Stewart equation is Stewart equations. The first Stewart equation, v equals u plus a times t. Exactly the same equation we are getting here when you take the cross product of a and t. So we are getting the same equation. This equation takes the form of a t equals v minus u, or we are keeping v as the subject, then you will get it as u plus at. So this is the same equation as the first Stewart equation. Now let us solve it for v. So v equals, u is 0 because it's starting from rest, and the acceleration we already calculated in the first part. It is 1.1. So let us use that number here. It is 1.1 and for a time of 2.4. So on calculation, make use of your calculator, and on calculations, it is giving an answer of 3.1 meter per seconds. 3.1 meter per seconds. This is the answer we are getting. So the acceleration already calculated here, that same number acceleration you have to use here. It is 3.1. So approximately we are getting, so whatever they are telling, approximately it is 3 meters per second. This is what they have to, they are telling us to show that the velocity is 3 meters per second. We got it. Now let us move on to the next part of the question. There is a graph given. When you are solving the graphs, the first thing is, please see what is marked on the x-axis, what is marked on the y-axis. So this graph is what type of a graph? Because you have different type of graph. You have displacement time graph, you have velocity time graph. So this is the first step you have to see. So this is a velocity time graph. And we know that the velocity time graphs are always telling you something about acceleration, because using velocity and time, what we can calculate is acceleration. So this talks about acceleration. Now, the question is, which feature of the velocity time graph shows the distance traveled by the sledge? Now, from the velocity time graph, we can even calculate the distance traveled by the body. So which feature of the graph? So how do you know that? How do you calculate? This is what they are asking. So we have studied that from the velocity time graph, the area under the graph or the area under the plot, that is the distance traveled. So which feature of the velocity time graph? This is the area. So we are going to write area under the graph. Under the graph or area under the plot equals distance traveled. Now let's move on to the next part. Describe the motion of the sledge during the journey between shown by the velocity time graph. See, it is the journey is divided into three parts here. O to A to B, and B to C. describe the motion of the sled during the journey. So describe means you have to say what type of motion it is, whether the body is at rest or the body is moving with a uniform speed or it is accelerating or decelerating. Now let's see one by one. The first part, that is O to A. For a velocity time graph, if you are getting a sloped line upward, that means the body is moving with an acceleration. That is, there is a uniform increase in speed, acceleration or a steady increase in speed or increase in velocity. So this is what the first part says. So we'll write it's O to A. O to A, the body says that it is increasing at a constant rate, that is velocity is increasing at a constant rate, or you can even say that the body is moving with a constant acceleration. So body is moving at constant, steady acceleration, steady or constant, constant acceleration. Now the part A to B, you are getting a straight line. See, you are getting a straight line. That means even though the time is changing, the velocity value is not changing. That means the body is moving with a uniform velocity or constant velocity. So A to B, uniform or constant velocity. These are all uniform, steady, constant. These are all same meaning only. Uniform or constant velocity. Now the next part of the journey, that is B to A, it is sloping down. That means instead of the velocity increases, B to C the velocity is decreasing. So here you can see B to C the velocity is decreasing. So here the velocity is increasing. So this is a case of uniform deceleration, steady or constant deceleration or uniform deceleration. Uniform deceleration. Okay, as I told you, always the velocity time graph is indicating something about acceleration. So first part is constant acceleration, last part is uniform or constant deceleration, and the next one, the middle one is uniform velocity, means this also talks about acceleration. This means acceleration equals 0. So acceleration increases or steady acceleration, velocity increases, velocity constant, that means acceleration 0. Then uniform deceleration means the acceleration deceleration is constant or a steady decrease in velocity. Now let's move on to the next part. This is a question from 19 January 1P. So this is a question talking about investigation of the motion of different falling masses by measuring the time taken for a toy parachute to fall from a window. So this is, as you see, there is a mass attached to this parachute. There is a mass attached. This is the mass. Now, the student does, he measured the mass of the toy parachute. He dropped the parachute from the window. Repeat the experiment with additional mass added to the toy parachute. Continue to add masses up to a maximum of 6 different masses. Describe how the student should measure the time taken for the toy parachute to fall from the window. So they are just asking, how should he measure the time? Measure the time. So as you know, we are using a stopwatch or a stop clock to measure the time. So start the time when it is released and stop the timing when the parachute hits the floor. This is what he has to do. It's just a 2-mark question only. So let us put it as an answer. Use a stopwatch. First of all, use a stopwatch. Or a stop clock, then start the time, when released, when the parachute, when the mass is released, when released, and stop timing when it hits the ground, hits the ground or hits the floor. Then state the independent dependent variable in this investigation. So independent variable means uh, the, the, the quantity or the variable that we set or we control, we set it, we change its value, we control the value. And the dependent variable is what we measure as the final output from the experiment. So it is definitely here the dependent variable is he is measuring the time taken for the fall. So dependent variable is time taken. Time of fall. I can say the time of fall. Now, what is the independent variable? What is he controlling or what is he fixing and doing? The mass attached. Okay, see it is given here. He additional masses he is adding to the parachute. Continue to the last bulletin. Continue to add the masses up to 6 masses. So the mass is the independent variable. So mass of the mass added, it is the independent variable. Mass of the block, it is the independent variable. Now next part of the question is state one factor that the student should keep. That means he is asking about the control variable. What we should keep constant throughout the experiment. Control variable means throughout the experiment. See, independent variable also we are varying it. In steps we are varying or we are choosing and varying the independent variable. But control variable is a factor that is constant throughout the investigation or throughout the experiment. So here as a constant uh, or a control variable, we can consider the height from which the parachute is released. So we can say height from which it is released. Now the next one, there's a table for different masses, 20, 40, like that, different masses, 20 to 120. He measured the time 3 times, trial 1, trial 2, trial 3, different trials. Then he averaged them and complete the table by calculating the average time for the mass for 120. As you see here, one box is incomplete, so we are asking you to complete it. So taking the average means adding the trials over how many trials you have taken. So we can say T average. So what is the T average here? T average. It is 0.90 plus 0.88 plus 0.85 and this is 3 trials. So on calculation it is giving an answer of 0.8766. As you see here, it is two significant figures, some are three significant figures. So the maximum it can go up to two significant figures. So it will be 8, 7. The next one is 6. So rounding up 0.88 seconds. So let us put that number here, 0.88 seconds. This is the average time. Now the next one is draw a curve of best fit. So this is just to to save time, I copied the mass, that is the first column, and the last column, the average time, because they need a graph of the average time and mass and average time. So I just copied it, and let me include the last value what we calculated, 0.88. Now let us plot the graph. So when you are plotting a graph, the first step is labeling the x and y axis with the proper units. So what are you taking on the x axis and what are you going to take it on the y axis? So this is y axis and this is x axis. So now here we have already seen that the mass is the independent variable. Usually we are marking independent variable on x axis. So I'm going to take mass on the x axis. So you have to write that one, mass in kilogram, mass in kilogram. So that I label it with the unit. Next one, the time. Time is our dependent variable, what we are measuring, the time in seconds. This is the first step. Now the second step is, let us find out a suitable scale. Here you can see that the mass is changing from 20 to 120. So 20 to 120 means I think we can mark it in steps of 20. This is 40, 60, 80, here comes 100 and here comes 120. These are the x-axis marking. Similarly on the y-axis it is changing from 0.8 to, this is 0.8, okay, 0.8 to 1.48. 0.8 to 1.48. So we can mark in steps of 0.4, something like that, 0.4. Let me see, 0.8, 1.2, 1.6, 1.2. Okay, we can go in steps of 0.4. This will be 0.8, then this will be 1.2, then the next one is 1.6 and this will be 2.0. Let's start marking the points. For 20 it is 1.68. This is 20. 1.68 means it will be 1.661. Okay, so how do we find out how many division is, or one division is the value of one division, small division? Here you can see 0.6 to 20, the value is 0.4. 0.4 is for 10 divisions. So here 10 divisions, 10 division is 0.4. Therefore, 1 division is 0.4 over 0.4 over 10. So this will give a value of 0.004. 0.4 over 10, it is 0.04. So the first division will be 0. Here, okay, the first division is 0.0408, then 1.08. Yeah, 0.08 will be the second division here. This is the value. Then for 40 it is 1.26. 40, 1.26. This is 40. 1.2, 1.2 and 1.26. 1.6 means it will be somewhere here. The next one, 60 is 1.11. 1.11. So this is 0.8, 0.884, 0.84, 0.88, 0.92, 96, 1, 1.04, 1.08, and so this will be somewhere here. Now for 80, it is 0.99 for 80. 80.99 means this is from 0.8, 0.84, 0.88, 0.92, 96, 98. So it will be somewhere here. Then the next one is 0.93. 0.93 also somewhere closer to that. 0.9993. Then last one is 88. 0.88 means it's at the rate 0.84, 0.88, it is here. So this is the value I am using, 1 division, this one, okay. 1 division equals, this is the number I am using. 1 division is 0.04. So in that way you have to calculate. The question is draw the curve of best fit. So you have marked all the points, then slowly you join them. I think it is not joined correctly, but judge by your eyes and join it. So this is the expected graph. See, look at the marking here. On the grid, plot a graph of average time taken and mass. In fact, you have to write it as average time. Average time. And you can see that there are 4 marks for that question. That means labeling the axis have some specific marks. Then taking the proper scale have some specific marks. That way only it is split at 4 marks. And just after plotting the points, just joining the points, you are getting only 1 mark. So other things are very important to increase your marks. Then the next part of the question is, the student notices that the toy parachute accelerates and then falls at a constant speed. So he notices that when you are dropping the parachute, first it is accelerated and then it moves at a constant speed. After that, speed is not changing. This is what is given at the start. This is at the start, then part of the path down, then near the bottom. Explain, there is a question here, sorry. First part, the arrows in the diagram shows the size of the direction of the forces acting on the toy parachute at different points during its fall. Label the forces on the diagram. And definitely the arrow downward is, this is showing the weight or the gravitational force, the weight downward, and it is moving through air, passing through air. So it is air drag or air resistance, okay, or air friction we can say, air friction. Next part of the question is explain why the toy parachute accelerates and then moves at a constant speed. So in the beginning, the moment he releases the parachute, or the moment he drops the parachute or releases the parachute, there is only a downward force acting, that is a gravitational force. There is no air resistance. Okay, the moment, so I'm writing the moment, see, as you see, this is the first picture. See, there is no upward arrow shown. See, this is the first picture given. Then another one here, another one here. Please look at this one. In the first picture, there is no upward arrow given. That means no air friction or air resistance. So in the beginning, okay, at the start, at the start, there is no air resistance or air friction, air resistance. Only the weight downward. The direction of the weight is always, it is vertically downward. Look at the first picture. Then after that, what is happening? So there is only a resultant force downward. There is an unbalanced force downward. So there is an unbalanced force which causes an acceleration. So there is an unbalanced force downward which causes an acceleration. So the acceleration is downward acceleration. Okay. Now after that, as it passes through the air, the speed is increasing. Therefore, the air resistance is also increasing. So let us write that part. As it moves, that means as it falls down. I can say as it falls down or as it moves down, the air resistance increases because speed increases. Now it is coming towards Earth. So the pull of Earth, it is coming in the same direction of the pull of Earth. Therefore, the speed is increasing. As the speed increases, the air resistance is also increasing. Exactly the same thing, only they are showing in the second picture. Okay, see the second, as a second part they are showing, no, there is a upward air resistance. Okay, so finally, so as it is falling down, the speed is increasing. As a result, the air friction also increases. And finally, at some stage, look at the third picture, the air resistance become equal to the weight. That means these two become balanced. So at some stage, finally or eventually, the air resistance balances the weight. That means air resistance become equals weight. The air resistance become equal to the weight means now there is no acceleration. The parachute falls down at a constant velocity as acceleration becomes zero. Okay, eventually the air resistance balances the weight and The parachute falls down at a constant velocity. Why? Because the acceleration is zero. Because there is a balanced, these two forces become balanced and the acceleration reduces to zero, so it is falling down at a constant velocity. Let's move on to the next part of the question. The student investigate how the surface material of a ramp affects the average speed of a block sliding down the ramp. Design a suitable method for the student's investigation. Your answer should include the measuring equipment needed. Okay, so your answer should include, see, there are 3 points they are telling. Let us number them 1, 2, 3. There are 3 points. The measuring equipments, the details of dependent, independent variable, control variable, and how the student should measure the average speed. You may include a diagram to help. You may include. Okay. The student investigate how the surface material of a ramp affects the average speed. So this is about a ramp. Ramp means it is like a slope. It's about a slope. This is the ground level. Okay. A block sliding down the ramp. So there is a block. This is the block. It is sliding down the ramp. This is the ground. Okay. Now your answer should include. Okay, what is he doing? He is investigating how the surface material of the ramp affects the average speed of the block. That means for different surface materials, he has to measure the average speed and then only he can conclude. Okay. So, we understood that he has to measure the average speed. So, average speed, the speed means it is, how do we measure the speed? We know that speed or velocity, it is the distance over time. Distance over time. This is the way only we measure the speed. Speed S. Let me write it as speed only, otherwise you may get confused with the displacement S and so speed. So speed is distance over time. So you have to measure distance, you have to measure time, then only you can calculate the speed. And also we know that to measure the distance, we need a measuring tape or a ruler. And to measure the time, we need a stopwatch or a stop clock. So let us include, from the first point, we can say like the student needs a measuring ruler or a measuring tape. Okay, measuring equipments needed, equipments needed. Equipments needed. Number one, measuring tape or a ruler to measure distance. The second one is he needs a stop clock or a stopwatch to measure time. This is sliding down, sliding down, sliding down along the ramp. Then these are the two things as the equipments. Now let us answer the second, instead of putting it as numbers, second bullet. Details of the independent, dependent and control variable. This you have to write. So first one is independent. Independent variable. Then it is dependent. Then it is coming to the control variable. So, uh, independent variable means in the experiment what uh, we select and vary, what we choose and vary. Okay, we are choosing that and we are varying. So here, since the student is investigating how the surface material of a ramp affects, that means he has to do the experiment with the different surface material of the ramp. Okay, so he has to choose a different surface material. Therefore, the independent variable can be here the surface material, smooth surface or a little hard surface or a wooden surface or whatever it is, surface material. This is the independent variable. Now the dependent variable is measuring the time. When the experiment as an output, he is measuring the time. Therefore, he is measuring the not the time, he is measuring the average speed. He is measuring the average speed, or he is calculating the average speed. So the dependent variable here is the average speed. Of course, he is measuring the distance or time, but the final output from the experiment is calculating the dependent, as a dependent variable, he is calculating the average speed. So average speed is a dependent variable. Distance and time he is measuring, fine, but the final output from the experiment is calculating the average speed. Therefore, dependent variable is the average speed. Now, what about the control variable? Control variable is, it should be of the same, you have to keep it fixed throughout the experiment. As an example, we can say the mass of the block, or the weight of the block, or the size of the block, even the material of the block, you can add it. So independent variable, surface material; dependent variable, it is average speed; and finally the control variable is the mass. So this is the one, average speed is here, and control variable is the mass or weight or size of the block. Now let us check what is the third one. How the average speed will be determined. So what is a method to calculate or find the average speed? So this is the third one. So let us mark it as a third bulletin point. How to write the third one? Uh, so he has to measure the time for the ball to reach the bottom of the ramp 3 to 4 times. That is different trials. Then take the average of the time, and using that average time, calculate the average speed. So this is measure the time taken. Measure the time taken by the ball to reach the bottom of the ramp. Repeat 2 to 3 times. Time measurement. Then calculate time average. That means average, and use it in the calculation. Average speed equals distance over the time. Time means here I can say T average. because to improve the accuracy of the investigation, we are doing this for different trials, measuring the time and taking the average, and that average we are using here in the calculation of the average speed. Calculate T average. This part we are doing to improve the accuracy of the experiment or investigation. Justify why the student should display their results as a bar chart. So usually when the data is continuous, we use a line chart, but here the bar chart is used because the data is not continuous. It's a discontinuous data because different materials he has used. So it is not a continuous data. Okay. Uh, the material, so we can say, suggest why the student should display the results as a bar chart, because surface material used is because surface material. They are changing the surface material. Used is this used, it's a discontinuous variable. Usually line graph is for continuous variables, but this is a discontinuous variable. Now the next question is, the graph shows how the velocity of a parachute jumper changes with time. At point A, the parachute jumper is falling at a terminal velocity. So terminal, here it is, the terminal velocity means with a constant velocity. So at A, so this part is a terminal velocity they are telling. Which statement is correct? Which statement is correct about the parachute jumper at point A? So see, he is moving at terminal velocity means it is a constant velocity. Terminal velocity means constant. Terminal velocity is constant velocity. Constant velocity. Constant velocity means acceleration is zero. Acceleration is zero means the net force sigma F is zero. Okay. So net force is zero means, as we know in all parachute or skydivers jumping, finally at some stage the weight of the body downward, the weight of the body downward become equal to the air resistance upward. These two forces become equal. Okay, this is weight and this one is air resistance. This is what is happening in all skydivers and parachute at the moment they gain the terminal velocity. So this much we know. From the word terminal velocity, we know this much idea. Acceleration is zero. That means the two forces, upward force must be equal to the downward force. Now let us see one by one. Acceleration and air resistance are equal. No, acceleration and velocity are equal. No, this is not true. This is not true. Weight and acceleration are no. Weight and air resistance, yes. Here we have seen weight. This is the weight. Downward one is weight. The upward one is the air resistance. These two are equal. So this is the correct answer. D is the correct answer. Next part is, which is the best estimate of the distance fallen by the parachute jumper from the start until point A? Until point A. So here, until point A means the best estimate. We know that from a velocity time graph, we can calculate the value as the area under the graph. But as you see here, until point A means This is point A until this point. So if I am taking till here, actually this much is this area before A, from the origin till A. That area is the distance travelled. But since it is not a regular shape, we cannot use any equations like area of a triangle or area of a rectangle, something like that. So here it is only a best, look at the word itself, it is just a best estimate. Estimation only. Estimate means approximately. So we have only the counting the square method we have. Okay, you can see I'm going to count the squares here. 1, 2, 3, 4, 5, full squares, 6, 7, 8, 9, 10, then it is 11, 12, 13, 14, 15, 16, 17 and 18, 19, and this one with a small part from here, we can say 20. Then this one with a small part from this side, it is 21, and the next one 22 with the upper one, this one, this is also 22. So approximately 23 squares. So I'm just writing approximately 23 number of squares. It is approximately 23. And what is the size of one square? One small square. So this is 0. So this number is 10. And this number is also 10. So 10 times 10, it is area of square. Area of square equals 10 times 10, it is 100. Therefore, what is the area of 23 squares? We have 23 squares. This is 23 times 100, which will give an estimation of 2,300 meters. So this is the expected answer. This is the correct answer. So we are counting the number of squares. Number of squares 23. Area of one square, it is 100. From that, for 23 squares, it is 2,300. Now the next part of the question is, the parachute jumper operates his parachute at point B. Her velocity decreases until she reaches a terminal velocity again at point C. Explain this change in velocity. This is after opening the parachute, that is A to B, it is terminal velocity, and at B, he opens the parachute. So when he opened the parachute, how the velocity decreases until she reaches the terminal velocity again at C. As you see, at C, there is a constant velocity drawn like this. So from C, the velocity is remaining the same, constant. So that part only they are asking you to explain this change in velocity. Okay. So again, when he opened the parachute, so let me put it as an answer. When the parachute is open, the air resistance increases as surface area increases. Because when the parachute opens means the surface area of the parachute is increased. So as the surface area increases, the air resistance increases. So now there is always a downward force, the weight, but here what is happening is when the surface area increases, the air resistance increases. Now the air resistance greater than the weight. So resultant force upward. We know that the air resistance is upward. Upward force is more means, so resultant force upward. So she decelerates. She is falling down. At the same time, the resultant force is upward. So her speed is decreasing. She decelerates. So she decelerates and her speed decreases. Next part, as speed decreases, air resistance decreases. Air resistance is always depending on speed. When speed is more, air resistance is more. As speed decreases, air resistance decreases. If the speed increases means air resistance increases. Here speed decreases and air resistance decreases. And eventually the air resistance become equal to the weight. Eventually become equal to weight. See, please look at here. The beginning we see that the air resistance is more than the weight. See, the air resistance is more than the weight. And since the speed is decreasing, finally at some stage air resistance become equal to weight. Look at the change. Air resistance become equal to the weight. So when the air resistance become equal to the weight means there is no resultant force. No resultant force. So acceleration is 0 and she gains another constant speed. Constant speed or constant velocity. This is what is happening. Now, after point C, the parachute jumper continues to fall at a constant velocity. As she falls, energy is transferred from a gravitational store. Which store is the energy transferred into? See, when she is with the parachute, when she is landing on the ground, okay, due to that friction, some of the energy is transferred to thermal energy because due to friction. Friction on landing. Friction on landing. Okay, some energy is converted to heat energy or thermal energy. Now the next part of the question is, or next question itself is, the diagram shows a van accelerating along a horizontal road. The horizontal forces acting on the van shown here. You can see there is a force X and there is a driving force 2500. Force X opposes, the arrows are given, it opposes the van. State the name of the force. It's very obvious that the force that is opposing the motion or the direction of motion, opposite to that only the friction force is coming. So state the name of the force X. It is force of friction or friction force, you can say, force of friction. The resultant force acting on the van is 1500. Calculate the magnitude of force X. The resultant force acting is 1500. So this is the van. So we have the van. van is given here, and here is one force, that is 2500 Newton, and here is the resultant force X, which is 1500 Newton. Calculate the the resultant force is given. Not this is not given. The resultant force is given. X you have to calculate. X we have to calculate. And we know that the resultant force, I'm going to write it as sigma F, resultant force. It is, the two forces are acting in the opposite direction, 2500 minus X. And the resultant force is given as 1500, which is 2500 minus X. So this will give X as 1500, 2500 minus 1500. It will give an answer of 1000 Newton. The force X is 1000 Newton. This is the picture I have given to show you the forces acting. Okay, so the X is 1000 Newton. Net force is 1500, and already the driving force is 2500. X is opposite direction, so subtracting, it will give you an answer of 1000 Newton. Now the next part is state the formula linking resultant force, mass and acceleration. I think this is a repeated question. This is a repeated question. Sigma F, resultant force, sigma F is the product of mass and acceleration. The mass of the van is 1900. It is the mass given. Calculate the acceleration when it brakes. So we have to calculate the acceleration. And we know that resultant force, it is the product of mass and acceleration. Therefore, acceleration resultant force over mass. And the resultant force, it's already given as 1500, and over the mass is 1900. On calculation, this will give you an answer of 7.4 meter per second square. Please make use of your calculator. It is 7.4 meter per second square. Now the next part of the question is the van was traveling at an initial speed of 80 before braking and coming to rest. So initial speed, let us represent this by U, and coming to rest, that is the final speed V. Calculate the distance traveled by the van while it is braking. Assume the acceleration remains constant. So they are asking you to calculate the distance traveled. So we can make use of the SWOT equation, V square equals U square plus 2AS. Because the other equations are with the time, we cannot use them because the time is not given here. So this is the only convenient equation we can use here. This S only they are asking you to calculate. Okay, so let us take this 2AS. 2AS, so we'll bring it here, V square minus U square equals 2AS. Now I am writing it here, the rest of the thing. Therefore, S is equal to, keeping S as a subject, it is V square minus U square over 2A. And V square is 0 and U square is 18 square, and divided by 2 times the acceleration. The acceleration, it is given, or we calculated it as 7.4. Already we calculated here, it is 7.4. So it is 2 times 7.4, and on calculation it is giving an answer of 22 meters. Please make use of your calculator to get the answer. So I'm using the SWOT equation, and S is unknown. So I'm taking 2As, separating 2As, and from that taking S as the subject, V square minus U square, but we know that V is 0 at rest, coming to rest, so V equals 0. So the answer is 22 meters. Coming to The next question, a car driver sees a hazard on the road ahead. The graph shows the velocity of the car from when the driver sees the hazard. Use the graph to determine the reaction time of the driver. The reaction time of the driver is, that is before he brakes, before he apply the brake. His thinking, the thinking time only we call it as the reaction time. Before the action starts, braking starts, it is a reaction time. And from the graph you can see that the reaction time is this part. This part is the reaction time. And we can read it as 0.9 seconds. Calculating the stopping distance of the car. The stopping distance. The stopping distance of the car is the area under the graph. So the first part, there is a one portion and there is a second portion, and the first portion is giving the thinking distance and the second portion is giving the area under the second portion is giving the braking distance, and the stopping distance is stopping distance. Stopping distance equals thinking distance plus braking distance, plus braking. Thinking distance plus braking distance. Area 1 is thinking distance, this area, this is thinking. Area 2, this will be the braking distance. So they are asking you to calculate the stopping distance, which is the sum of area 1 and area 2. As you see, area 1, so I'm just writing this is area 1 plus area 2. Now let us see what is area 1. Area 1 is like a rectangle. So the rectangle area is length into height or length into width. I'm just writing it as L times B, length into breadth or something like that. Area 2, it's a triangle, half times the base times the height. So let us substitute, I'm doing it together. So we can say the length, it is 15 times the base, it's coming like 0.9 plus for area 2 it is half times, base is 4 minus 0.9, this is the base, times the height is coming as 15. So on calculation, calculating this part plus calculating this part, together we are getting the stopping distance. Let me write it here, stopping distance. Stopping distance is, the first part answer is 13.5. 13.5 plus the second part is 23.25, and all together it is giving an answer of 37, approximately 37 meters. Please make use of your calculator for the calculation, 37 meters. So here the stopping distance is asked. Stopping distance means the full distance. You can do this question even with making use of the equation of the area for a trapezium. Complete figure looks like a trapezium. That way also you can calculate the stopping distance, the area under the graph. Now calculate the acceleration of the car when the car is braking. When the car is braking. So acceleration is it is delta V over T. So from the graph, I'm taking the values from the graph. delta V, accelerate, it is before stopping means the deceleration part, okay, the second part. So it is the velocity is changing from 15 to 0. But here the initial velocity will come as 15 and the final one is 0. 0 minus 15 over the time is from 0.9 till 4. So I told you it is from the second part. Acceleration of the car when the car is braking. Braking is the second line or second part of the graph. Braking, the second part. So this will be giving you an answer of negative 4.8 meters. This is the answer. Now the next part of the question is, the speed of the car affects the thinking distance and the braking distance. Discuss other factors that affect the thinking distance and the braking distance. There are many factors affecting thinking and braking. It's a 4-mark question, so let me write it this way. First one, thinking. Thinking distance. The other one is the braking distance. Okay, the thinking distance, at least 2 you have to write because this was given as a 4-mark question. At least 2 you have to write. So thinking distance, first of all, it is the condition of the driver, whether he has consumed any medicines or alcohol or something like that, or it's tiredness, I can say. Tiredness of the driver. The second one, we can say the speed of the car, thinking. And the braking distance, it is the condition of the tires or the condition of the road. Then another one, we can say the mass and weight of the car, mass of the car plus passengers, total mass of the car, or okay, this is another factor controlling the braking distance. And in fact, the braking distance depends on the speed of the car also. There is a third one. So speed of the car is coming as a common factor for thinking and braking. Now the next question is, this question is about stretching a spring. So Hooke's law, extension, force, such things. Draw a cross on the line to show the elastic limit of the spring. Elastic limit means the straight line part. So use your ruler until where the straight line is coming. Use your ruler for this one. So just by look, I think till here it is the straight line. Okay, elastic limit of the spring means it is a straight line. End of straight line, I can say. End of straight line. Then sketch another line to show how the extension will change when the force is decreased from its maximum value back to 0. Draw another one to show how the extension will change when the force is decreased from its maximum value. The force maximum value is this one. This is the force maximum value. From here, when you are removing the load, where as you add the load, the extension is increasing. Similarly, when you are removing the load, the extension is slowly decreasing. That sketch only they are asking. Sketch another line to show for a spring as you go on adding the masses, extension is increasing. Delta X increases. Similarly, when you are removing the load or mass one by one, what is happening? The extension will decrease. Okay. So sketch another line to show the extension change. So extension change means extension has to decrease from its maximum value back to 0. So this is the maximum value of force, F max. This is F max. This position only F max is given. So from here, when you are removing it, so the extension is decreasing, extension is decreasing. See, maximum extension is this point. This is the maximum extension, okay? But when you are removing it, this is coming back to this position. So this is the graph. This is the expected line. Sketch another line. So this is the line. So this line on removing the load, on removing the load, removing the weight. This is the graph you are getting. Okay, this way. And now you can see that on removing the load completely, it will not regain its initial stage. There is a permanent extension produced. So this part is, we can call it as the permanent extension. This is a permanent extension produced. Now the next part of the question is, state which energy store of the spring increases when it is stretched, assuming the spring does not reach the elastic limit. So it is elastic potential energy. Elastic potential energy increases. So spring energy or elastic energy is a form of potential energy, elastic potential energy. How is the energy transferred to the spring? How is the energy transferred to the spring? So the energy is transferred mechanically. It is not electrically, not by heating, not by radiation. So the correct answer is mechanically. This is the correct answer. We are coming to the next question. The diagram shows a coin being dropped from the height. There is a graph given, velocity time graph given. Calculate the acceleration of the coin as it falls and give the unit. So this is from the graph we have to do. And the graph, this is one velocity, and this is calculate the acceleration of the coin as it falls. So the time is, this is the final velocity. It comes as some 6.1 this way, okay? 6.1, and the initial velocity is 0. So we can write acceleration. It is a change in velocity over time, and it is y2 minus y1 over time. Y2 is, this is y2 and this is y1. So it will be 6.1 minus 0 over, in fact this is t2 and this is t1. So time is t2 minus t1. So this numbers will give me the answer as 6.1 over The time is till 0.662. Till here it is 62, 0 to 62. So 0 to 0.62. On calculation, this is giving an answer of 9.8. So the answer is 9.8. Since it is an acceleration, we can give the unit meter per second square. So 9.8 meter per second square. State the feature of the graph that shows this acceleration. So state the feature of the graph. From where do we calculate in the graph? Which part of the graph, or how do we calculate it? We calculate it as the gradient of this, the gradient of the line. Gradient of the graph or gradient of the line or the graph. I can see the gradient is giving you the acceleration. Calculate the height from which the coin was dropped. Use the graph to help with your calculation. Calculate the height from which, the height. But they are telling you use the graph. That means using the graph you have to calculate. See, usually to calculate the height distance we are using Suvat equation. No, but here this you have to calculate from the graph, or you can take the values from the graph. Okay. So you can use a Suvat equation but take the values from the graph. So in the Suvat equation here, to calculate the height, that means distance they are asking. So let us use the Suvat equation. S is ut plus half a t square. And here instead of a, I'm going to write it as g because it's a vertical motion. So this will be, the initial velocity is 0. See here, s you have to calculate, and when a body is dropped down, always the initial velocity is 0. And the final velocity from the graph, we can see that it is reaching a final velocity of 6.1 meter per second. Then since it is a vertical motion, acceleration is g, and that too it is falling down. Therefore, it is positive g, which is 10. I think here we have calculated. So here you can take it as 9.8 meter per second square. Then time. Time is also given. Time is 0.62 seconds. So using all these values here, this will become 0, then half times 9.8 times 0.62 the whole square, 6.8 the whole square. On calculation, it is giving an answer of 1.88 meters, approximately 1.89 meters. So this is the answer we are getting. So it is 9.8 times. Now we are coming to the next part of the question. The ball is dropped from a very large height. The graph shows how the velocity of the ball changes until just before it hits the ground. Explain why the velocity of the ball changes in this way. Refer the ideas about forces in your answer. Let us have a close look at the picture graph. You can see that the graph, the velocity is increasing, and see, before it hits the ground, it takes a constant velocity. You can see as a straight line. That means it is a constant velocity what they are showing. Okay. So whenever when it is falling down, it takes a constant velocity. We have seen or we have studied the skydivers or parachute. It gets a constant velocity on its way before hitting the ground, and we call it as a terminal velocity. So the same ideas we can use here to complete the answer. So it is same like question 4b part. Okay, similar. similar to question 4 part B. We have answered similar question, but here let us answer it again. The moment you drop the ball, there is only weight acting, there is no air resistance on the ball. Therefore, the resultant force is downward, so it is accelerating downward. So let us put it as an answer. The moment the moment the moment the ball is dropped down, there is only weight acting downward. That means no air resistance, air friction or air resistance. So net downward force making ball to accelerate downward. This is the first part. Then as it falls down, the speed is increasing, therefore the air resistance also increases. So next part is as it falls down, as the ball falls down, the air resistance, I am putting the symbol increases just to save the time and space, but exam tried to put the complete word. The air resistance increases because speed increases. Speed increases. Eventually, air resistance become equal to weight. So air resistance is upward and the weight is downward. So the upward force become equal to downward force. Now, what is the net force? Net force sigma F equals 0. So acceleration equals 0 and the ball gains constant velocity. Zero acceleration and the ball gains constant velocity. I put it in 3 steps. The moment, the beginning, initial, there is no air resistance, there is only a net downward force, therefore it is accelerating downward. But as the ball falls down, the air resistance increases. This means it is increases because the speed increases. Eventually, the two forces become equal. The upward force and the downward force, both of them become equal. Net force become equal. Acceleration is according to Newton's second law. Newton's second law. And the ball gains constant velocity.